This tutorial video will look at the events to produce an action potential or nerve impulse. This is a typical neuron with dendrites, cell body, axon, myelin sheaths, nodes of Ranvier, and terminal branches. At rest, a neuron has sodium ions and potassium ions in specific areas within the cell body. Have a think about where there is a high concentration of sodium ions and where there is a high concentration of potassium ions. Hopefully it looks something like this. Sodium ions are highly concentrated outside the neuron and potassium ions are highly concentrated inside the neuron. This distribution, along with other ions, creates a voltage of negative 70 millivolts inside the neuron. That is our resting neuron before we send an action potential. In the first stage of an action potential, a stimulus is received and ions start to move. This stimulus must reach a threshold of negative 55 millivolts for an action potential to be sent. Once the threshold is reached, all other events will follow the same sequence. The second stage of an action potential is depolarization. Looking at the resting neuron, what will happen to cause depolarization? Sodium gates open and sodium ions will enter the neuron. Why do they enter? By diffusion, sodium ions will move from an area of high concentration to an area of low concentration. On a graph, we see a stimulus causes threshold of negative 55 millivolts to be reached. Then we see depolarization caused by sodium ions entering the neuron, which increases the voltage inside the neuron to about positive 40 millivolts. After this stage, what will happen next? The third stage of the action potential is repolarization. Potassium gates now open and potassium ions exit the neuron, again by diffusion. The fourth stage of the action potential is hyperpolarization. Because potassium gates stay open a little longer than the sodium gates, more potassium has exited the neuron than sodium entered. On the graph, we see that repolarization caused by potassium ions exiting the neuron changes the voltage inside the neuron back to negative 70 millivolts. And we see hyperpolarization caused by extra potassium exiting the neuron, reducing the voltage further to about negative 90 millivolts. At this point, why can't we send another action potential? And how do we fix that? After depolarization, repolarization, and hyperpolarization, sodium ions and potassium ions are now in the wrong places. In stage 5, we have a refractory period. This is when another action potential cannot be sent. We need to pump sodium out of the neuron and potassium into the neuron to get back to rest. Because we are moving ions from an area of low concentration to an area of high concentration, we use a sodium-potassium pump and actively transport the ions with the use of ATP. This restores the neuron to its resting state, ready to send another action potential. That is the sequence of events to send an action potential or nerve impulse. Have a look at the resting neuron and the complete graph and see if you can now talk through the sequence of events on your own. The following slide has a summary to check your learning.